a few topics in 8th grade that you will see and actually recognize as an adult constantly. The first thing that you learn in 8th grade that you're going to use for the rest of your life is something called the Pythagorean Theorem, made by a man named Pythagoras. Reagan called this theorem last year the Pirate Theorem. I have no idea why, but now I kind of have the urge to always call it the Pirate Theorem and make story problems that are pirate-based. So if you call it the Pirate Theorem, well, I'll have a chuckle and I'll remember. But it is actually called the Pythagorean Theorem. So the question is, what is the Pythagorean Theorem? Well, the Pythagorean Theorem only works with right triangles, and this is probably the most important part of it. It is true for all right triangles. So this doesn't work for isosceles triangles. It doesn't work for obtuse triangles. Unless the triangle is right, this will work. So a right isosceles would work for that type of stuff. But if it's not a right triangle, Pythagorean theorem does not work. So what the Pythagorean theorem says, if we have this side of the triangle is a leg, and this side of the triangle is the other leg, the third side is a term called, and let's say it together, hypotenuse. In fact, if you come and say hypotenuse to me during class, you will get one piece of candy. If the hypotenuse is always the opposite side of the right angle, so the hypotenuse is the longest side of any right triangle, the Pythagorean theorem states that if you do a leg squared plus the other leg squared, that'll be equal to the hypotenuse. I'm going to spell this wrong. There we go. Hypotenuse squared. The other way that you will see this written is if we call this side A and this side B, and the hypotenuse always has to be C, the statement A squared plus B squared will always be equal to C squared for any right triangle. And that is the Pythagorean theorem. So, an example of the Pythagorean theorem in practice is if we have, and we call this a right triangle, we have the side 3 meters, this side being 4 meters, and the hypotenuse being x. We can do a squared plus b squared is equal to c squared. Well, we know that x is c, so this will stay as x squared. This is 3 meters, so this can be a or b. It doesn't matter. So we do 3 squared plus 4 squared, and we set that equal to x squared. Well, 3 squared is 9. 4 squared is 16. We set that equal to x squared. And now we have just a regular equation. We can actually draw a line through our equation and solve it just like we used to. 9 plus 16 is 25. And that's equal to x squared. This is the step that I always recommend people actually writing down, because the next part is a little bit different than what you did before. In this part of an equation, you always do the opposite of whatever is with the x. So if this was 2x, you would divide by 2, right? But if it's x squared, the opposite of squaring is square root. Therefore, we then square root both sides. Well, the square root of x squared is just x, and the square root of 25 is 5. Therefore, x has to be 5 meters. Well, we know that's true now by, if we plug it back in, we do 9 for 3 squared. 4 squared is 16, and 5 squared is 25. And that is a true statement. Therefore, x has to be 5. Now, if we move on to another problem, the answers can be irrational numbers. And if you remember, irrational numbers, one example would be a square root that is not a perfect square. So square root of 10 would be an irrational number because there is no perfect square that would be this answer. So in this problem, we will actually have an irrational answer. And what will happen is, in this case, still a right triangle, that's still the hypotenuse. So this will be either a or b. So we'll do x squared plus 6 squared. We'll set that equal to 8 squared. Once again, we can draw the line down our equal sign and solve just like we used to. This is 64. This is 36. x squared will stay the same. Now, since our hypotenuse is 8, our answer better be less than 8. The number one mistake people make here is they will add these numbers instead of subtracting, and they will end up getting an answer that is incorrect. So we get x squared is equal to, in this case, will be 28. Now, once again, we want to do the opposite of squaring something, which is square rooting something. So we get x is equal to the square root of 28. And to find the answer, we will then plug this into a calculator. So we will go square root. Whoops, let's try this again. This calculator wants to go backwards. So 28, and then I click square root, which gives me around 5.29 or 5 and 29 hundredths. Okay, so since it's not exact, we're going to write in the little squiggly equal signs, and we'll say 5 and 29 hundredths. So that is our answer to this problem. Now, since this is an about, if we plugged it back into the problem, our answer would not be exactly correct. So make sure when you're answering in a full sentence, you would say about. So let's do a story problem without the story here, just a picture. You see Pythagorean theorem problems most often in construction or architecture or things like that. So here's an example of when this could actually be used in the real world. Let's imagine we have a wall here, okay? And on the wall, we have a 10-foot ladder. We know it's a 10-foot ladder because we bought it and the box said 10 feet, okay? Then when we set that ladder up, it's set up at an angle, and we want to know how high up the wall did the ladder go. Well, this creates a right triangle with the 10-foot ladder being the hypotenuse. We can then get out a ruler or a tape measure, and we measure that to be exactly 5 feet. So we are going to solve for x. Well, in this case, we're going to do it just like we did before. So we have x squared plus 5 squared, and we're going to set that equal to 10 squared. Once again, we have an equation. Draw our line down our equal sign. 5 squared is 25, so we get x squared plus 25, and 10 squared is 100. Now, to solve for x, I'm going to subtract 25 from both sides, and so I get x squared is equal to 75. Okay, here's the step that's easy to forget. The opposite of squaring is square root. So I have x is equal to the square root of 75. This is calculator time. So I clear this out. I do 75, and then I square root. And it's 8.66, or 8 and 66 hundredths. So I type that in. There we go. And we're going to say about 8 and 66 hundredths feet. And since it's a story problem, you would say the ladder reached about 8 and 66 hundredths feet up the wall. And that is the end of the Pythagorean theorem. As always, if you have questions, please let me know as soon as possible.